Hello guys, welcome back. Now we have learned how to make a line plot and now we are going to learn how to create a box plot into the use of the C-bond. So as we have already, if you have already known about the box plot, it is really important if I'm talking into the respect of the machine learning. Box plot is really important and to understand it, it's actually very important. So for that, we are just going to start the box plot. So I'm just taking a random data for creating a box plot. I'm just taking a random data that is t is equal to not t. Let's take a dr is equal to taking a random data 4, 7, 9, 11, 13, 14, 19, 21, that 50. Okay. So now we have taken these value as a random data as a list and we are saving it. Okay, we have taken this random data. After that, what we are going to do, we have already imported our Cbond library. So we'll write that sns dot box plot, and inside this we'll pass our data that is dr. Right now it's into the form of list, no issues into this. We're just going to pass the data and yeah, let's run it. As you can see, this is the box plot that you are getting for this data. Okay, this is the box plot that you are getting for this data. Now we have to actually understand what's the real meaning of it and what is the purpose of it and why we use it. These are really important question as respect to your box plot, and understanding it's pretty much good. So the below line that you are seeing here, this line, so we call it as a minimum value. Minimum value. So as you can see, it's around you are getting 4. So this will be your minimum value. As you can see, this is your 4 in the list and this is 4. So this part, this value, we will call it's a minimum value. Now the next thing, this part, this SARP is. So we can call it as a 25 percentile value. 25 percentile value. Now, uh, what is the percentile? This is really a good question. The percentile. So it is the extended version of your percentage. It is the new way to find out the ranking of any value. So these are the some statistic term. We will more explore about this term whenever we learn about the statistic in our upcoming data science module. This for now, just understand it as a 25 percentile value and which is called it as a Q1 value. 25 percentile value and Q1 value. Now this part you can call it as a 50 percentile value, or you can call it also as a median value. 50 percentile value or a median value. Now the next thing, this part you are seeing. So we call it as a 75 percentile value or Q3, third quartile range. Q3, third quartile range. So first it is Q1, that is first quartile. This is Q2, that is second quartile, and it is also called median and 50 percentile. And this is Q3, that is third quartile or 75 percentile value. Now this value, you will call it as a maximum value. Maximum value. Let's check what is the maximum value in our list. Oh, it's 50. It's 50. So where 50 gone? If you can see this little dot, now this little dot, this is the actual maximum value. Actual maximum value. But right now, this bar, you will consider it as a maximum value. This is the minimum value and this is the maximum value. Minimum, maximum. Now, what is the difference? And what does this mean of it? So this value that you are seeing as a dot, we can call it as a outliers. It as a outliers. And now this outliers, what does it means? Okay, so we will understand further more about the outliers and why this 50 coming it as a outliers and how this 25 percentile is coming, minimum value is coming, median value is coming, and 75 percentile value is coming. We'll more understand about these things in our statistic part. Okay, for now, we have this minimum value Q1, Q2, Q3, maximum value, and the outliers. Okay, now just by seeing the data, just see this data 4, 7, 9, 11, 13, 14, 19, 21. Just see how gradually it is increasing. Like 4 plus 3, 7 plus 2, 9 plus 2, 11. Like this, it's increasing gradually. But after 29, it suddenly jumps to the 50. It suddenly jumps to 50. Okay, it's a huge change. It's a huge change. And this change, generally, we can call it as a outliers. And this you will see whenever you will plot a box plot. And it is really important to find out the outliers. Why? Let's just understand as a data scientist purpose. Now see, understand it. You created a machine learning algorithm in which you pass the data, in which you pass the data. Now, machine generally finds some pattern into it. Machine generally finds some pattern out of your data. So what it does, okay, it's coming 4, then coming 7, then coming 9. Okay, I'm understanding this pattern. It is increasing the number by 2. So I can predict what will be after 21. So it can be 23 or 24. But what is happening? It is getting 50. So after gradually increasing, this sudden change into the data or the sudden change in the data can cause to the less accuracy of your machine learning algorithm. And that is really true. If you are making a sudden change in your data, how machine will going to understand? It generally finds a pattern in your data, then it is able to predict something. Okay, so these kind of thing we have to find out. Outliers, we have to find out from our data so that we can remove this outlier or we can tackle it with some other tactics, that is standardization or normalization of the data. We'll explore more about it. No worries, we'll explore more about it. Now, if you find the outliers, you generally remove it or tackle with some data. After removing the outliers, you can pass your data into the machine learning algorithm, and that will generally increase the accuracy of it. And thus, how important is to create a box plot for understanding the data outliers. Okay, so this is important for finding out the outliers, and thus you can create and tackle with it, and after that you can pass this data in machine learning algorithm and predict it out of there. Okay, so right now we are just passing dr. Let's try to pass any common value that we have right now. So we have this fair column. Let's try to pass this fair column in our data frame, in our box plot. So for that, for accessing the fair column, you will write data dot fair, fair, fair. Okay, let's pass this. As you can see, we are seeing a lot of outliers. See, lot of our box plot is making perfectly between 0 to $87 or 80, around $80, I can say. After that, it is doing a little dot. You can see little. Now these will be considered as your outliers. Now these values that you are seeing, it will be considered as your outliers. Okay. Now, as you have seen the fair column, generally people were coming into the middle class value, like there were around 50 to $60. After that, there were not much people, and there was coming sudden change into our data also. Okay, so those things were happening in our fair column, and that's why you're seeing a lot of dot values, lot of dot values. Either you can remove it to increase the accuracy of your result, either you have to tackle it with normalization, standardization, and all other tactics. Okay, so these are the things that we have to do. These are the things that we have to do with our data set. Okay, now this is all about our box plot, and we'll meet into the next video. Bye bye, guys.